Live from Earth, it's Space Radio. This is Paul Sutter, and coming up, we're talking about is Starlink ruining astronomy? And of course, taking listener questions about all things in the universe, because that's what this show is about. We record every Thursday at 8 p.m. Eastern, and you can follow along online or leave a voicemail at spaceradioshow.com. And in today's Blue Shift, I'll be talking about space versus ground. The battle continues, but first, the news. Hey, Space Cadets, welcome to Space Radio. I'm Paul Sutter, astrophysicist at Ohio State and the Flatiron Institute, and for the next half hour, your agent to the stars. We've got an exciting show for you today, where we talk about all things space, astronomy, astrophysics, rocketry. If it's above the Earth's atmosphere, it's in this show's universe. This show lives on listener questions. We record every Thursday at 8 p.m. Eastern here at Spaceman Studios in New York City. So leave a voicemail at spaceradioshow.com to get yourself on the air. You can also follow along with our Space Cadets on the live stream, tuning in live from around the world. I love the around the world rundown, including but not limited to Ashburton, New Zealand, Pell City, Alabama, Maggie Valley, North Carolina, New Orleans, Folkestone, UK, Lancaster, California, the third best Lancaster in the States, and Germany, and so many other places. We will take questions. I will take questions. There's only me. There's only me, and I'm going to do all the answering. I'll take questions that you send there too. Seriously, folks, 10 minutes. Tops. That's what I've got going on here that I've prepped. This show is run by you, mostly me, but you get to contribute, so get those questions in. Hey, Space Cadets. First, I want to do a level check. I know the past few episodes, my microphone's been a little bit funky. Adjusted the gain down here. How's it feeling for you guys? Let me know. Where's Greg, and is he okay? Greg is alive. Don't worry. He spends most of his time locked in his room, but I let him out at least once a day so he can see the sun, so he can run around in the park outside the apartment complex. But he spends most of his time inside. But he seems happy. He's more of an inside Greg, really. He's good. He's happy. He's in his happy place. Don't worry about him. Yeah, let's talk about Starlink while we get some questions rolling in, guys. Sound is good. Thank you. Okay, good to know. Good to know. Greg, Siren Modern Dance. I know, Greg. And he's listening. Don't worry. He listens to these episodes because he turns them into the radio show. He edits them. So if you have a message for Greg, let me know and I will say it to him. I will tell him. Before I start taking questions, I want to share some interesting bits of news I caught recently. And man, everybody is all a hubbub about SpaceX's Starlink and what it might do to astronomy. So if you haven't heard, SpaceX, the private space company by Elon Musk, one of the things they're going to do, the whole point of SpaceX is to make access to space cheaper by using reusable rockets. So yay, it's cheaper. One of the things they plan to do with it is to launch tens of thousands of communication satellites, so-called mega constellations of satellites that will all fly in unison to give worldwide high-speed internet access, which is awesome. On the other hand, if you're an astronomer, it's not so fun to have tens of thousands of highly reflective objects moving through the night sky because you're trying to take pictures of the stars and nebula and distant galaxies, and it can kind of be ruined by bright things moving through your field of view. You could just mess up your photographs. You can mess up your data collection. And all of this discussion was hypothetical until recently, when some astronomers using some massive telescopes down in Chile were doing some long exposure science runs. They were doing their normal astronomy thing, and they looked at their results, and there were these sets of streaks moving across their image. And they're like, okay, that was a waste of time. Thank you, Starlink, for just they don't even have tens of thousands of satellites up yet. They just have a few dozen, but already it caused some issues with one particular observing run. So SpaceX has come out. They said, look, we understand. We want to provide worldwide internet access, but we understand astronomy is a thing and we want to respect that. So we want to coat future satellites in absorbent material so they're not as shiny. We want to fly them in certain orbits so that they won't be a problem for most of the major observatories. We want to work with the astronomical community so that if there's a planned major observing run, we can steer the satellites away from them. They haven't done any of those things yet. They say that's the goal. In terms of astronomy, it doesn't ruin every kind of observation. It really only ruins observations that take long exposures. If you really need to stare at one chunk of the sky for a very long time, that increases the chances that a satellite is going to cross your path. It's really only a problem at near dusk and dawn where they can catch and reflect a lot of sunlight. If they're just not reflecting a lot, if everything's not aligned just right, they're just not going to show up anyway. So it's up for debate. I don't really have a side here. I mean, yeah, yay astronomy, but also yay global high-speed internet is kind of a cool idea. I'm hopeful that there will be a dialogue going into the future over the next few years, because SpaceX isn't the only company planning on launching mega constellations of tons of satellites, way more satellites than we can even comprehend right now. Where will the discussion go? Where will the discussion take us? Will there need to be some compromises on both ends? Most likely. Is astronomy in real existential danger? No, I don't think so. Is it going to cause some issues for astronomy? Most certainly. Hopefully, I'm asking. If I had a direct line to Elon Musk, I would pick up the phone right now and ask him, like, hey, this whole being nice to astronomers thing, astronomy has been around for a really long time. It's relatively well regardless. We're rather harmless as a scientific discipline. I mean, all science is harmless, but we're relatively benign. We're just trying to figure out how the universe works. Can you cut us some slack? All right. Can we come to the table and talk about this? Also, can we maybe use your high-speed internet access for our science? That's all I'm saying. But remember to leave a voicemail or follow along live at spaceradioshow.com. That's where you find the links to everything. That's the latest and greatest when it comes to space. But let's answer some questions. Yes, nerdy Ronins. Ordering cheese over Starlink. That is the pinnacle of human civilization. I do have some voicemail questions stacked up, so I'm going to hit one of those for the first segment, and then Space Cadets, you better get me some good questions. I'm counting on you. I'm counting on you to make this show good. And the only message I have for Greg is Disillusion on Twitch saying, we love you, Greg. Disillusion ain't alone. We all love you. All right. We've got a voicemail ready to go. Hey, Greg, why don't you play that tape?
Hi, Paul. It's Steve from Aberdeen, Scotland. We've all heard that black holes spin, and that we can detect this spin from the effect it has on the accretion disk surrounding the black hole. But my question is, what is spinning? It can't be the singularity. That's a dimensionless point. What's the angular velocity of a dimensionless point? That doesn't make any sense to me. I've also heard that it is the event horizon which is spinning. But the event horizon is just a boundary. It's not made of anything. How can something which is not made of anything spin? One thing that is definitely spinning is my head. Can you help?
Wow, Steve from Aberdeen, Scotland. What a wonderful question. I totally get what you mean when you're faced with these kinds of questions and just trying to understand the concept of spin when it comes to a black hole. I understand why your head is spinning. I honestly, when I try to think about this too deeply, I get a runny nose. It's just bad overall. You're on the right track when you're asking, what does it mean for a black hole to spin? If we think about what a black hole really is, it's a singularity. It's a point of infinite density. It's a puncture in space-time itself. That is the black hole. The event horizon is just a mathematical boundary, the line in the sand that tells us where the point of no return. If you cross the event horizon, you can't get back out. So how does this thing that isn't even really an object as we understand it have spin? And I'm going to tackle this through a couple different ways. One way is to think about fundamental particles. If you think of an electron or a quark or a neutrino, these fundamental particles take up no space, they have no volume, and yet they do have spin. An electron has a property that we call spin. It looks and acts and feels like it has angular momentum, like a little top spinning around. But of course, that's not really true, because as you said, an object with no spatial extent, how can it really have momentum? And yet here it is. You're surrounded. You're made of particles that take up no space and yet also spin. So that maybe isn't as crazy an idea as it sounds. Another thing when it comes to black hole spin is that you can ask the exact same question about, say, the mass. How is an object, the singularity takes up no spatial extent, the event horizon is just a mathematical line in the sand, how can that thing have mass? How can it have weight? How can it have gravitational attraction? How can it have any influence at all on the outside world? If you can come to terms with that a black hole can have mass, then is it that much of a leap to say that a black hole can have spin? Really, where I'm going with this is that black holes are objects of pure gravity. They are just regions of space-time that are totally 100% dominated by gravity and absolutely nothing else. And gravity can do more than pull things in. Gravity can make things spin. It's allowed in the equations of general relativity, which is how we understand black holes. Gravity can also talk to electric charge. And so black holes are completely and totally summarized by three properties and three properties alone: their mass, their total spin, and their electric charge. If you have those three numbers, you can completely define and characterize a black hole. That's everything you need to know about black holes. Why? I hate to retreat to the mathematics as just the answer, but it's in our understanding of black holes, which we get through general relativity. You can plug these three numbers in. The equations allow these three numbers to coexist, and then you can understand black holes, or you can predict their properties, you can understand their behavior. That's not entirely satisfying, I understand, so let me briefly take another tack, which is to say, when you see a black hole, when you feel a black hole, when you encounter a black hole, what you're feeling, that gravitational attraction that you're feeling to the black hole, doesn't come from the black hole itself. It comes from the star that died to create that black hole. Remember, from our perspective, outside of a black hole, nothing ever really crosses the event horizon. Stuff really does, but from our perspective, we never see it cross. So as that star collapses to form a black hole, it leaves behind a shadow. This shadow still has mass. This shadow still has influence in the outside world. And that's what we feel when we get near a black hole. The mass of the black hole is really the mass of all the stuff that fell in its past, the star that collapsed to form it, and all the gas that fell in since then. And that is what we feel. If that black hole has an electric charge, it's not that the black hole itself has an electric charge, but all the stuff that fell in had an electric charge, and we still feel that. And same for the spin. You don't really feel the spin of the black hole itself. Instead, you feel the spin of all the stuff that fell into the black hole. You're still feeling or seeing the spin of the star that created the black hole and all the material that fell in. When you encounter black holes, I don't want you to think of it as encountering an object that exists in the universe. It's more like you're encountering a memory of something that used to exist in our universe. Thank you so much for that question, Steve. We're going to take a quick break, folks, but don't forget to leave a voicemail or join the conversation or catch the live stream on YouTube and Twitch. Visit spaceradioshow.com for the links. I'm Paul Sutter. This is Space Radio. This show is brought to you by you. I'm not joking. Go to patreon.com/pmsutter to learn how you can support the show, and I'll see you after the break. Wow. What an intense question. Black hole spin. I love it. And tons of Space Cadet questions as usual. I love it. How do I eat all that cheese? Love it, love it, love it. All right, I'll just start from the top with these questions. And, you know, I'll try to get through as many questions as possible. Oh, wow, this is so much fun. Yes, tons of questions. Wow, thank you guys. And thank you again, Nancy, for getting all these questions to me. It's a treat. It's a treat. You guys, you ready to go? Do little stretches, because it's going to be 9 minutes of nonstop science fun. Here we go. Welcome back, everyone. I'm Paul Sutter, and this is Space Radio. We've got more questions ready to go, but remember, you can join the conversation by leaving an online voicemail or by following the live streams. Check out spaceradioshow.com for all the links. Now, to the Space Cadets, it is their time to shine. And man, do they have some awesome questions, starting with Matthew DeFleury on YouTube asking, how do I eat all that cheese and stay thin? Well, thank you for the compliment. If you don't know, if you're listening to this as a podcast or a radio show, at the end of every show, I kind of eat cheese. In fact, there is some cheese that I'm looking at right now, and it's a different cheese every week. I bring up a picture of Greg, and we share some cheese and some memories and some laughs, and it's a great time. But you can only catch it on the live stream. And how do I eat all that cheese? Well, you know, I don't know. Maybe it's magical cheese that actually consumes calories rather than releases it. I don't know. I'm just going to go with that. Anyway, moving on. Campbell Duncan on Twitch is asking, what are the benefits of going to the moon other than using it as a leap pad to Mars? This is, the perennial debate about moon versus Mars versus asteroids versus Venus versus anything else versus just staying put. This just goes on and on and on. I don't really have a huge stake in it myself. The moon has some advantages in terms of human habitation or colonization or exploration. Mostly the fact that it is right there. Like, you can point to it almost every single night or every single day. It only takes a couple days to get there. And so if something goes wrong, or we need to adjust something or fix something or update something or pull people out or put people in, it's only a couple days away. Mars is months away, and space is already hard enough as it is. And then trying multi-month, multi-year missions, which is what any round trip to Mars is going to take, it just becomes exponentially harder and more expensive. So what's the advantage of the moon? It's close. And you know what? In space, that matters. Nancy Graziano, the Space Cadet Wrangler, is asking, how did TikTok go last week? Last week, oh, this was so much fun. Last week, myself and Siren Monitor Dance in New York City, we were in Houston at the Houston Museum of Natural Science performing TikTok, which is our exploration of the nature of time. I am lucky enough to narrate portions of it. It's set to Mozart. It's gorgeous choreography. The dance company is fantastic. I love working with them and I love performing with them. And we were very, very lucky because we performed in the central atrium of the Houston Museum. And suspended above us was an art installation of a gigantic photorealistic moon. I'm talking, this thing was at least 50 feet across, if not bigger, suspended right above our heads. And so we got to perform to a great audience underneath the moon inside the museum. It was an absolutely magical evening, and I love performing, and I love telling the story of what we know and especially what we don't know when it comes to time. Edward Hinton over on YouTube is asking, if we find life in the solar system, how do we know it's alien and not, say, panspermia? How do we know it really evolved there? And the answer is, we won't know until we actually have to find life outside the Earth, and most likely bet something that we can actually get our hands on is in our own solar system. And we're going to have to ask, did this evolve here? Did this evolve somewhere else and then get here? Did we contaminate it accidentally? We won't be able to tell. This whole panspermia idea strikes me as a little bit off, just like the odds of everything you need to line up to get life originating on one planet and then through a series of cataclysms and unfortunate and fortunate events ending up seeding life on a new world. It turns out it's just easier for life to just natively evolve somewhere else. It's just less work that you have to do, and so it's much more likely. But once we get our hands on it, we're going to have to test it. We're going to have to test its DNA, if it even has DNA. That'll be a big sign, right? If it's a completely different base, a completely different way of organizing information within living structures, that's going to be kind of cool. And obviously didn't come from here because this is all we got. So, fun question, and I really, really hope we get to explore that question in our lifetimes. Siren Monitor Dance is at, hey, Siren Monitor Dance, how's it going? My collaborators on TikTok, or I should say I'm their collaborator on TikTok, is asking what happens when a Magnetar tries to eat another one. So, neutron stars, which can become very, very highly magnetized, and then we get to call those magnetars. Neutron stars do occasionally slam into other neutron stars, and it's pretty scary. It's a pretty scary thing. Like, imagine, I have this instant visual in my head. Like, imagine a bunch of spiders, and then imagine a bunch of, like, scary bloody spiders with like big fangs, and they're crawling all over you, and it's just frightening. Okay, I just want to give you that mental image of something scary. When neutron stars collide, it is definitely something very scary. They blow up. They blow up in something we call a kilonova. Kilo meaning 1,000. They're about 1,000 times brighter than a typical nova. Kilonova, when they occur, they emit enough energy that they fuse some of the heavier elements, especially gold. They're very fond of making gold. So very, very likely, if you can point to something gold on your person or in your room, very, very likely that came from one neutron star trying and failing to eat another. And unfortunately, we're almost out of time today on Space Radio. I know, it goes by so quick. But before we go, it's time for the blue shift. Wow. I love it when there's more questions than I have time to answer. And I know. I've been saying this for over a year that I've been working on ways to make this show longer. I mean it. Don't worry. I haven't given up on you. Other things I've given up on, but not you. Not you. I'm Paul Sutter, and you're listening to Space Radio, and this is the Blue Shift, my opportunity to get a little bit closer to you. And I want to talk about satellites. I want to talk about astronomy. I want to talk about space, and I want to talk about the ground. We have satellites. We have observatories up in space. Hubble Space Telescope. We have TESS. We have Chandra X-ray. We have the Fermi Gamma Ray Telescope. We have Spitzer Infrared. We're going to have James Webb, maybe. And we have tons of telescopes on the ground. Small ones, medium ones, big ones, extra large ones, big, large, huge ones. We've got all sorts of telescopes all over the place. So which is better? Having an observatory on the ground or having an observatory up in space? Well, the answer is it depends. Generally, going to space is ridiculously expensive. And the launch costs aren't really the big factor here. The big factor is you have to make a precision astronomical instrument that can survive the harshness of total vacuum of outer space. Not a friendly environment, not an environment that you can just send a repair crew up. We did that once with the Hubble, and that was a joyride. But not something we really do on the regular. On the other hand, there are some things we simply can't see from the ground, right? The atmosphere of the Earth is really good at blocking certain kinds of electromagnetic radiation. It's really good at trapping infrared, hence this whole greenhouse thing. It's really good at blocking X-rays. It's really good at blocking gamma rays. And so if we want to see the universe as it really is all across the electromagnetic spectrum, there's some things that are just invisible to us from the ground, and we have to go into space. And there are certain observing strategies and patterns and modes of observing and targets that the atmosphere presents too much of a challenge for us and that we can't really work around. And yet, we can make a lot of progress from the ground. And dollar for dollar on space versus ground, most of the time, ground is going to win. You can simply build a much larger telescope and get access to a lot more information, a lot more data than you can from space. But there are certain special cases of where you just can't do it from the ground, period. It's just too difficult, too complicated. And so the dollars are best spent somewhere else. So who's going to win, ground versus space? The answer is us. We're going to win. Because no matter what, we get to learn something about the universe. And unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of space radio. Once again, I'm Paul Sutter, and this show is brought to you by you. Visit patreon.com/PMSutter to learn how you can contribute. Thanks to Greg Moebius for producing, Nancy Graziano for wrangling the Space Cadets, and all the fine crew at WCBE Radio for making this show possible. Catch the live stream every Thursday at 8 p.m. Eastern. Visit spaceradioshow.com for more info and links to the live streams. And of course, thanks again, Space Cadets, for listening. See you next week. And remember, science is for sharing. End of transmission. Wow. Yep, Twitch chat won. Twitch it. But it's time. It's time to bring Greg in. Hey, Greg, how's it going? Missed you, buddy. It's been a couple weeks. Where are you? I got you here. Hey, Greg. How's it going, dude? You're going to like what I brought today. A classic. I brought a classic. Like some weeks I like to go a little bit farther afield. And some days, as soon as I open the bag, I smell it. Parmesan. Parmigiano. Now, this is not Parmigiano Reggiano. It's just, I don't know, some random brand. It's gluten-free, good to know. Aged 10-month Casaro brand, Parmesan. Crafted in Wisconsin. I like that word, crafted. Because you can you smell it? Guys, can you smell that? There is nothing like the smell of good Parmesan, let me tell you. And I know. There's so much snobbery surrounding Parmesan cheese. Like if it's not Parmigiano Reggiano, then like what are you doing? You might as well be eating, the plastic that wraps around the cheese. You might as well just root through the trash and eat that if it's not going to be the real thing. Everyone's a fan of Parmesan, period. I mean, the saltiness, the nuttiness, a little bit of tang. You just eat it on your own, on its own, as I am right now. You can put it inside of things, on top of things. Too hard for you? Okay. You like the soft cheeses? That's fair. Here's the thing. When it comes to Parmesan, I'm not gonna be a Parmesan snob. Why? I did live in Italy for a couple of years, and in my time, during then and since, I've had the opportunity to eat the most high-end, super duper aged Parmigiano Reggiano, super expensive, right? And I also ate Grana Padano, which is, like Italians like called like the poor man's Parmesan. That's way cheaper, way more common. Maybe I have an unsophisticated palate, which is fair. Maybe it's all a massive marketing conspiracy, also fair. But I couldn't tell the difference between the super fancy Parmesan and just Grana Padano. Which, if you haven't had Grana Padano, go get some. Because you'll be like, wow, this tastes like Parmesan, and I only paid like 1/10 of it of the price. So, and just Parmesan itself has so many applications and so many uses. If you're shredding up Parmesan, this is my personal opinion. I know I'll be labeled as a heretic. If you're shredding up Parmesan to put in something else, are you going to taste the difference once it's mixed with all those other flavors? If you're eating it by itself, you might notice, but I didn't. You might. Maybe you have a more sophisticated palate than I do. But you know what? To me, a good Parmesan is good Parmesan. And that's all the more you need to think about it. I'll see you guys next week. No, I won't, because it's Turkey Day. Turkey Day next week, so no show. But then after that, we're going to be all nice and fat and happy and having a great time. And we'll talk about science. See you then.